Hi, welcome to CAP, Quantum Academy for Physics. In this lecture, I am going to derive a few more dimensional formulas. And the dimensional formulas must be written by using fundamental physical quantities. And these must be written in single letters. Like mass is written in a single letter, capital M, and length, capital L, and time, capital T, single letter. They must be written in single letters. Amperes, capital A. Okay, and these must be written by using only fundamental physical quantities. And these must be enclosed in square brackets. Okay, length, capital L. We have to write the dimension formula by capital L, and these must be enclosed in square brackets. Okay, ampere, capital A, and it must be enclosed in square bracket. Okay, and in this today's lecture, I am going to derive Planck's constant, frequency, relative density or specific gravity, stress, and few more dimensional formulas. Okay, what is Planck's constant? What is the expression for Planck's constant? From energy, we know that the formula for energy is E equals to h nu, where h is the Planck's constant. From here, from this equation, h, that is Planck's constant, is written as E by nu. Okay, the Planck's constant h is equal to E by nu, when nu is a frequency. So before writing the dimensional formula for Planck's constant, we will derive the dimensional formula for frequency, so that you can substitute this frequency nu in this equation. Okay, and what is nu? What is frequency? Frequency is equal to number of vibrations per time. Number of vibrations per time. Okay, so this can be written as 1 by T. Okay, so this number of vibrations, it's a number. Okay, so there will be no unit for number of vibrations, and for time T, this time can be denoted with capital T, and it must be enclosed in square brackets. See, in my previous lecture, I didn't use the square brackets. Why? Because I'm mainly focusing on ECET classes. So the main purpose for these lectures are to derive the dimensional formula. Okay, I didn't use square brackets. Okay, you just follow this sequence. You just add square brackets there for inter students. I'm telling about inter students. You just add square brackets. Okay, so nu is number of vibrations per time, which is equal to 1 by T, and the dimensional formula is m0 L0 T power minus 1. There is no mass, no length. Okay, and you just substitute in this equation. We had already derived this energy equation. Okay, energy dimensional formula is m1 L2 T power minus 2. m1 L2 T power minus 2 for energy, and you just substitute the frequency nu here, m0 L0 T power minus 1, and you just use square brackets. Okay, and now for Planck's constant, the dimensional formula for Planck's constant is m0 m1 is m1, L2 L0 is L2, T power minus 1, T power minus 2 and plus 1. T power minus 2 and plus 1 is T power minus 1. This is the dimensional formula for Planck's constant. And coming to frequency, nu is m0 L0 T power minus 1. and relative density are specific gravity. Now the relative density are specific gravity. The expression is density of substance divided by density of water. So in the numerator you are writing the dimensional formula for density, and in the denominator also you are writing the dimensional formula for density. Okay, this will be get cancelled, and this relative density or specific gravity is a dimensionless physical quantity. Okay, M naught, L naught, T naught. It's a dimensionless physical quantity. There are no dimensions. No dimensions and no units. No units. See, density have units and dimensions. But coming to relative density or specific gravity, in the numerator we have density and in the denominator we have density and no other physical quantities. So this relative density or specific gravity have no units and it's a dimensionless physical quantity. And coming to stress, what is stress? Stress is force per unit area. We have derived the dimensional formula for force and area also. And force dimensional formulas are m1, L1, t power minus 2, and for area it is L2. Okay, then m1 in the denominator you didn't have any m naught, t naught. Okay, if you write the complete dimensional formula for area, it is m naught, L2, t naught. Okay, m naught, m1 is m1, L1, L minus 2 is L minus 1, t power minus 2. This is the dimensional formula for stress. Okay, I think this is the same as pressure. Okay, same as pressure. In our ECET exam, the questions may be like this, as mentioned. What are the physical quantities? What are the physical quantities having the same dimensional formulas as stress? Okay, you have to derive the dimensional formula for each physical quantity, whatever given in the options. Okay, and you have to check the dimensional formula or the dimensions. You have to check the dimensions for each physical quantity, like 1 in mass, minus 1 in length, and minus 2 in time t. Okay, so next one, what is strain? The expression for strain is change in length by change in length by original length. Change in length by original length. So this strain is also having no units. Why? Because in the numerator you are writing the units for length, and also in the denominator you are writing the units for length. So this get cancelled, and the strain have no units and no dimensions. Dimensionless physical quantity. Okay, next, modulus of elasticity. What is modulus of elasticity? Stress per strain having no units and no dimensions. Then coming to stress, m1 L minus 1 t power minus 2. This is same as stress. Okay, modulus of elasticity having the dimensions the same as stress. Next, wave number. Wave number. What is the expression for wave number? Number of waves per distance. Number of waves per distance. A number of waves have no units. Okay, and distance is measured in terms of length, L. Okay, then what are the dimensions for wave number? M naught, L power minus 1, T naught. L power minus 1 and T naught. Okay. Next one is Boltzmann constant. The expression for Boltzmann's constant is energy per temperature. Energy per temperature. We have derived the dimension formulas for energy as M1 L2 T power minus 2. Okay, and temperature is measured in terms of Kelvin. Now, what is the dimension formula for Boltzmann constant? M1 L2 T power minus 2 into K power minus 1. K power minus 1. This Kelvin is also a fundamental unit name, right? Now, coming to the Poisson's ratio. What is Poisson's ratio? Expression for Poisson's ratio is lateral strain per longitudinal strain. So in the numerator we have strain, and in the denominator also we have strain. So this Poisson's ratio have no units and no dimensions. You can write this as M naught, L naught, T naught. Okay, and coming to surface energy. What is surface energy? Work per unit area. And what is the dimension formula for work? We had already derived it. M L2 T power minus 2. And what is area? M naught L2 T power 0. Okay, and this can be written as M1 L2 L naught T power minus 2. Okay, this is the dimension formula for surface energy. And coming to thrust. What is thrust? It's a pressure. Into area. It's a forward energy. We can call it as forward energy. Okay. It helps the rocket to move in forward direction, and also ships. Okay, ships in oceans or in water move in forward direction. Okay, and pressure into area. We had derived the dimension formula for pressure as M L power minus 2 T power minus 2, and area M naught L2 T naught. Then the dimension formula for thrust is M1 L power minus 2 and L2 is L naught T power minus 2. M1 L naught T power minus 2. Sorry, this is minus 1. Please check our before lectures. Pressure is M L power minus 1 T power minus 2. Okay, then we can write this as M L T power minus 2. And time period. What is time period? Number of oscillations. The time taken to complete one oscillation. That is one to and fro motion. The time taken for one to and fro motion of a pendulum. Okay, and it is measured in seconds. It is measured in seconds. The dimension formula is m0 L0 T. m0 L0 T. This is the dimension formula for time period. And next one is specific heat. Specific heat expression is energy per mass into temperature. What is the expression for energy? M L2 T power minus 1. So T power minus 2. And mass is measured in terms of M, capital M. The symbol for mass is capital M, and temperature in Kelvin. Okay. And now the expression is, the dimension formula for specific heat is M1 and M power minus 1 is M0 L2 T power minus 2 and K power minus 1. So the dimension formula for specific heat is M0 L2 T power minus 2 and K power minus 1. And coming to latent heat. What is the expression for latent heat? Energy by mass. Okay, what is energy? M1 L2 T power minus 2 divided by mass, capital M. So M power plus 1, M power minus 1 will become M power 0 L2 T power minus 2. This is the expression for latent heat. And coming to entropy. What is entropy? S equals to dQ by T, that is heat energy, change in heat by temperature. How can we measure this heat? It's a heat energy. Okay, expression is heat energy by temperature. Change in heat energy by temperature. You just write the dimension formula for energy here. Why? Because the dimension formula for energy and heat energy both are same. It has M1 L2 T power minus 2. By temperature is measured in Kelvin. Okay, now the dimension formula for entropy is M0 L2 T power minus 2. M1 L2 T power minus 2 into K power minus 1. And universal gas constant. What is universal gas constant? Pressure into volume by number of moles into temperature. Universal gas constant R is given as pressure into volume by number of moles into temperature. Okay. Now here number of moles, the unit for number of moles is mole. Okay, mole is nothing but amount of substance is measured in terms of mole. And pressure, what is the dimension formula for pressure? M1 L power minus 1 T power minus 2, and dimensional formula for volume is M0 L cube T naught by number of moles. This is MOL mole. Okay, it's also a fundamental quantity, and temperature in Kelvin. Now write the dimension formula for universal gas constant. M1 M0 M1 L power minus 1 into L power 3 is L power 2, T power minus 2 T naught is T power minus 2 into K power minus 1 into mole This is the dimensional formula for pressure. This is the dimensional formula for pressure. I am writing this here because it's not visible. Okay, expression for energy is mL2 T power minus 2, and for time T into length L divided by Kelvin, temperature, it's a temperature unit name, into area is 1 by L square. Okay, we just now solve this. M, you have left with only one m power 1, so m L2 L1 is L3 T power minus 2 and T power minus 2 divided by T temperature into Kelvin into L square. Okay, and this can be written as m1 L power 3 L power minus 2 is L power 1 into T power minus 2 T power minus 1 is T power minus 3 into K power minus 1 Kelvin. Okay, so the dimensional formula for thermal conductivity is M1 L1 T power minus 3 K power minus 1. This is the dimensional formula for thermal conductivity. I will end my lecture here itself. Okay, bye.